So now in this video, we're going to start to learn chapter 16, regression analysis model building. And in this chapter, we only learn the polynomial regression model, and we won't be extending to other regression models. The reason is because we learned chapter 14, 15, we learned the linear regression model. And so we're going to look at it if our first assumption linear relationship is violated, if you see the curvature in your scatter plot. So what you should handle in that situation. So therefore, we're going to look at the resolution for that situation. When you see the scatter plot, you see the curvature. So how you're going to modify your model. So this is basically what we're going to look at in chapter 16. And then we're going to look at the model selection, and that is how we're going to find the best model, especially when you have so many predictors in your regression model, such as your project. So you might collect 10 X variables. So do you have to include all 10 variables? Most of the situations not. So how you're going to able to choose the best model? So that's what we're going to look at in chapter 16, model building, including the polynomial regression model and our model selection. First, let's look at what do we mean by polynomial regression model? What's the rationale to guide you to use the polynomial regression model? So first of all, let's look at the relationship between the function and the graph. So the function and the graph. And so let's see, this is the linear regression model. So if you see any linear regression model function, it should look like y equal to a plus bx. And so this is by changing the value of the slope, we will have upward and downward curves. And however, if we add x squared to our equation, so how our curve will change. So by adding this x squared to your regression model, you actually notice that the curve will showing the curvature, right? So before, the curve is a straight line without this x squared, and now we actually will be able to see this curvature. So why I'm showing you the relationship between the curve and the formation of this equation? The reason is because think about the regression model we learned so far. So we are assuming x and y have linear relationship. So that's why we're creating that model look like y equal to b0 plus b1x1 plus b2x2. So none of the higher order of x is 2. So therefore, we're assuming x and y have a perfect linear relationship. So after we're learning from the last video about the diagnostic, we noticed that sometimes after you draw the scatter plot, x versus y, you might be able to see that the curvature. So how are we going to adjust our model to fit in that situation? So the answer is here. You just need to add in x squared to your regression model, adding x squared to your regression model, and then you will be able to capturing that the curvature you see from your scatter plot. So now we're going to look at if we do include x squared to your model, how do we name it? So what do we call the model that have higher order equal to 2 into the regression model? So before we look at the official term for the model that had the highest order equal to 2 in the regression model, let's review the rationale of using the polynomial regression model. The reason you are thinking using the polynomial regression model is because after you develop your collect your observation, develop the scatter plot, if you see the curvature, and then you're going to change in the functional form. So the functional form. So what do we call the function that the x squared, what do we call the model that including x squared in the regression model? So we actually call it a second order polynomial regression model. So before, when we look at the first equation, y hat equal to b0 plus b1x, so we call the simple linear regression model. The reason is because the highest order of x is 1. So this is our simple linear regression model. However, if we have x squared that is including our regression model, in that situation, we call it a second order polynomial regression model. Second order polynomial regression model. So if you look at this situation, the highest order of x is 2, so therefore we call it second order polynomial regression model. So now let's look at the implication of this model to the real world. So during the year 2005-2009, the world record for 100-meter dash was repeatedly broken as never before. We're using x equal to 1 through 5 to represent 2005-2009. So here is we're thinking to use a second order polynomial model to the data and estimate the world record time for 100-meter dash in 2014. So obviously we try to develop the the simple linear regression model. However, we're thinking to use the second order polynomial regression model. So I can explain the reason why. So first, let's look at our raw data. So as I said, we are using 1 through 5 to represent 2005 to 2009. So that's why you can see the second column in the table. That's the year X. So the Y is the time to break the record. So why we are thinking to use the second order polynomial regression model? So the reason is because after we generate the scatter plot. So let's draw the scatter plot on this on our worksheet. So when the year equal to 1, and then the y equal to 7.77, so which is about here, right? So then when year equal to 2, it still be 7.77, equal to 3, 9.74, which is about here. And year equal to 4, 9.69, 9.69. And then you're equal to 5, 9.58, 9.58. So this is my scatters. So if you try to find the pattern or try to draw the trend of this line, actually notice that we see the curve. So if you are still using the simple linear regression model, it won't be able to capture this curvature. So then what we're going to do, and then we're going to think using this kind of second order polynomial regression model, second order polynomial regression model. So after we learn so many regression model, you know that in order to get this result to get a best get estimate for B0, B1, and B2, we need the value for y, x, and x squared. However, if you look at the original data set, you will notice that we actually won't have the observation for the x squared. What should we do? So the idea here is we need to get the value for x squared so that we can estimate the value for B2, right? So where's the value for x squared? Since the value of x squared, since the name of x squared is called x squared, so the value for x squared should equal to the value of x and then square, right? So basically, you will use the value of year and then square, and year and the square, and the year and the square, and the year and the square, and the year and the square. So basically, we got 1, 4, 9, 16, 24. So that is the observation for x squared. So obviously, you notice that using the second order polynomial regression model. So there is one variable called x squared. The observation won't be able to observe. Instead, you are calculated. So based on the value of x. So after we receive this column, and then we can use the multiple regression model to run the regression. So then this is the result we got. Y hat equal to 9.728. So this is the value for B0, B1, and the B2. We're plugging back. And so now the question, if you look at the original question, we also asked to estimate the value for the time to break the record when the year is 2014. So if 2005 is 1, so then 2014 will be, yes, so the answer for 2014 will be 10. So then you plug in back to the equation, you got 8.58, and then you notice that, wait a second, does that make sense? So this is the wrong way to do the answer. And so the reason is because although the polynomial equation provides a good fit for the data during period 2005-2009, so this form is not appropriate to extrapolate the data out of 2014. Why? Because think about the sample data has to be able to use to representing the population. Your sample data only related to 2005-2009. So basically, your sample data won't be able to represent 2014 because from 2009 to 2014, there are a lot of changes, such as the swimming, the running shoes technology changed, and the coach, how they train the athletic will change. So your sample basically won't be able to represent in 2014. Therefore, you cannot use the model to predict what's happening in 2014. So basically, to answer the second question is you won't be able to answer because the sample cannot be used to represent the population. So before we move on to look at our the practice questions and the attendance check. And I want to mention one more thing is why we said the polynomial equation fit the data well. The reason we are using is we're using the adjust R square. So the adjust R square is 99%. So it's very, very close to 1. It's fit the data really, really good. So why we are using the adjust R square? Because usually we're comparing the this second order polynomial regression model with our simple linear regression model. Since these two models have different amount of the x variable, so one only have x, another has x and x squared. In order to compare these two models fairly, we have to use adjust R square.